Hi guys, welcome to our channel Helm of Science. Hope everyone is doing good. So in my last video I had started the chapter heat, which is quite an important chapter for class 9 students. So in my last video I had discussed about heat energy, like about the various units of heat. I had described 1 calorie, and I also had discussed with you guys thermal expansion. So just a recap, thermal expansion is caused like when like a metal rod expands on heating. There is an increase in length of the rod. This is known as thermal expansion. So there were 3 types of thermal expansion which I discussed. Those were linear expansion, superficial expansion, and cubical expansion. Linear expansion happens when there is an increase in length, superficial expansion happens when there is an increase in area, and cubical happens when there is an increase in volume. So for linear expansion, we had derived 3 formulas. If you remember, the formulas were LT minus L0 equals to L0 alpha T. So LT minus L0 was the increase in length. This L0 was the initial length, and this temperature, this T was a rise in temperature, and this alpha was known as the coefficient of linear expansion. So this alpha depends on the material. And alpha is like this. Alpha is different for different materials. Sorry. Now, so a coefficient of linear expansion for brass, for iron, for example, I am giving you just examples. So for the value of alpha will be different for each of them. So now from this expression we can write that alpha equals to LT minus L0 by L0 into T. Now LT minus L0 is the increase in length, so its unit will also be in terms of length. Let's say it's in meters, and L0 is also length, so it will be also meter, and say temperature is in degrees Celsius. So meter cancels, so the unit of alpha is per degree Celsius, or if the temperature is expressed in Kelvin, so per Kelvin. So the units of alpha will be Kelvin inverse or centigrade inverse. Now if you remember what I taught in the last video, I had like derived 2 formulas which were LT minus L0 equals to L0 alpha T. Also this is the first one, also LT equals to L0 1 plus alpha T. So these were the 2 formulas. For this is for linear expansion. Obviously for superficial expansions, like this LT terms are replaced by AT and A0 terms, and for cubical it becomes for VT and V0. So depending on these 2 formulas, like we have to keep in mind these 2 formulas to solve our numericals. So also there was another formula like alpha is to beta is to gamma as 1 is to 2 is to 3. So this was another relation. So these 3 relations we have to keep in mind for solving the numericals. So according to these new formulas, I will be solving few numericals for a better understanding. So we'll move on to the numericals. So the first numerical says that an iron rod of length rod of length 2 meters was heated from 40 degrees Celsius to 80 degrees Celsius. The increase in length was 1.60 millimeters. Find the coefficient of linear expansion. Now, what are the things which are given in the problem? Like the iron rod of length 2 meters. So this is the initial length. So we'll write down L0, which is the initial length, equals to 2 meters. And what is the increase in length? So increase in length is given, which was 1.6 millimeters. So increase in length, which is LT minus L0. This is nothing but the increase in length. This is final minus initial. So increase in length is 1.60 millimeters, which is nothing but, if we like express both in the same units, so it becomes 1.60 into 10 to the power minus 3 meters. Also, there was a rise in temperature from 40 degrees Celsius to 80 degrees Celsius. So T becomes 80 minus 40, which is 40 degrees Celsius. Now, if we put all the values in the formula, we will easily get the coefficient of linear expansion, which is alpha. So we know alpha equals to, from the formula, LT minus L0 by L0 T. Now if we replace these values in the formula, we get LT minus L0 is 1.60 into 10 to the minus 3. L0 sorry is 2 and T is 40. To make this calculation easy, like I'll shift the point, so it becomes 160 into 10 to the power minus 5 by 2 into 40. 0 0 cancels, 4. So it becomes 2 into 10 to the power minus 5 per degree Celsius. So the value of alpha becomes 2 into 10 to the power per degree Celsius. So this is your answer. So but now we'll move on to another type of numerical. Numerical 2 says that a metal plate of area 4 meters square is heated by a temperature of 500 degrees Celsius. The coefficient of superficial expansion is 1 into 10 to the power minus 5 degrees per degree Celsius. Find the final area. Find the final area. Sorry. Now what are the things which are given? A metal plate of area 4 meters square. So this 4 is the initial area, that is A0 is given as 4 meters square. Now it is heated by a temperature of 500 degrees Celsius. So increase in temperature is 500 degrees, and the coefficient of superficial expansion, which is beta, is also given. So beta is 1 into 10 to the power minus 5 per degree Celsius. Now so A0 is given, like T is given, B is beta is given. So we can easily find out AT by using the formula. We know AT equals to A0 1 plus beta T. This is the formula we know. So if we replace the values of A0, T and beta, we will easily get AT. So A0 is 4, 1 plus beta is 1 into 10 to the power minus 5, this into temperature is 500, this into 500. Now sorry, I am doing it here. I'll make the calculation a bit short, like this becomes 500 into this is 1.5 into 10 to the minus, okay, yeah, 1 2 3 4 5, yeah, 5 0 0 cancels, so it becomes 5 by 1000. So this becomes 4 by 1 plus 5 by 1000, which becomes 005 by 1000, which becomes 0204 by 1000. So becomes 4.02 meters square. So 4.02 meters square is our final area. So AT is 4.02 meters square. So this is our answer. Now I'll move on to another type of numerical which is quite often asked. Numerical 3 says that coefficient of cubical expansion, which is nothing but gamma, is 9 into 10 to the power minus 5 degree per degree Celsius. So 9 into 10 to the 5 per degree Celsius. So find number one, find alpha and beta. So these are the things which are given. Gamma is given. So we know the relation alpha is to beta is to gamma is 1 is to 2 is to 3. This we know. So from here we know that alpha by gamma becomes 1 by 3. So alpha is 1 by 3 gamma. So if we replace the value of gamma, we get gamma is 9. 9 into 10 to the power minus 5. Cancel with 3. It gets 3 into 10 to the power minus 5 per degree Celsius. Similarly, we will find out the value of beta 2. Beta by gamma becomes 2 by 3. So if we replace the value, 2 by 3 into 9, into 6 into 10 to the power minus 5. So these were the three types of numericals which are quite often asked from the chapter heat. So I hope these were easy and you all were able to understand. So now I'll tell you guys about the difference between heat and temperature. I had missed out this topic in my last video, so I'll cover this up in this video. So difference between heat and temperature. Now in my last video I had told you guys that heat is a form of energy, and I explained to you that the heat is formed in heat travels from one body to another due to the random motion of the molecules inside an object. While on the other hand, I told you that temperature is a measurable quantity, right? Temperature, this is the sensation of hotness or coldness of body, right? We can measure temperature with a thermometer. So the first point of difference is heat is a form of energy. It is a form of energy. It is a form of energy which arises due to random motion of molecules present inside an object. It is a form of energy which arises due to random motion of molecules present inside an object. So now what is temperature? Temperature is a measurable quantity. It is a measurable, also you no I have mentioned form of energy. So it is a measurable quantity which gives the sensation of hotness or coldness. So it is a form of energy which gives us the sensation of hotness or coldness. Now, as I mentioned earlier, we can measure temperature with the help of a thermometer, and heat can be measured by the principle of calorimetry. So measured by principle of calorimetry. On the other hand, temperature is measured by a thermometer. Now the next difference. Now this heat, it is due to the it depends on the it depends on the mass of the object, the material, and the temperature. Mass, material, and temperature of the object. It depends on the mass, material, and the temperature of the object. While on the other hand, temperature is the average kinetic energy of the molecules of an object due to the random motion. So it is the depends on the average kinetic energy of the molecules due to random motion. So the fourth difference is the SI unit of heat. I told you in the last video is joule expressed in with J, and on the other hand the SI unit of temperature is Kelvin expressed with K. Now the last difference between heat and temperature is, like I told you that heat and temperature are like related, are not at all related terms. So if two bodies are in the same temperature, the amount of heat contained inside them may be different. So if two bodies at same temperature may contain different amount of heat, while on the other hand two bodies having same amount of heat may differ in temperature. Yeah. So these were the few of the differences between heat and temperature. So this will be all for this video. If you find this video useful, please like the video, share the video and subscribe our channel. So thank you and see you in the next video.